So now we have a much more complex version of a perpetuity question. But what I want you guys to understand is that when we're dealing with perpetuities, we're always looking at the same set of information. We have our present value equals payment over k. However, sometimes you may be prompted or you may have to find a group of different set of payments. And you could group different set of payments in a bunch of different ways. And that's exactly what we're going to do in this question. And this is really one of the harder ones that they may throw at you, but being able to have exposure to this right now will give you a lot of chances to do super well on your exam. Once again, this is a harder question, but we're going to be able to do it step by step and also identify everything that we need to know in this question. So let us get started. The present value t equals 0 of the following cash flow stream is $1,000, $262.23 when discounted at 12% annually, okay? What is the value of the missing cash flows? X, assume the pattern of payments will continue in perpetuity. Every third year, there is no payment. Now, if you're like me, when you first saw this, you were like, this is some black magic. I don't get it. I don't know what to do. But with that being said, there's actually ways to group this information in cohesive manners. So the first thing that we want to do is, because we know that this is happening in perpetuity, okay, right here in perpetuity, we know that we could only be dealing with one set of functions. There's nothing else that we could possibly deal with. Like, there's literally nothing else. So let me just put the formula on the side for reference purposes. So we know that the present value is equal to payment over k. There's honestly nothing more to that. We know that at the very end, we need to find our PV, we need to find our k, and we need to find our payment. But fortunately for us, we were already given the present value at t0, which is given right here. It's $1,000, $262.23. So we already got that bad boy out of the way. Now we need to find our payments, okay? And clearly when you look at this graph or at this timeline, you're like, well, hey man, I see x, x, blank, x, x, blank, x, x, and so forth. But what I want you guys to be able to understand is that we're dealing with a similar set of patterns, okay? And check this out with me, and you can let me know in your head that if you agree with this or not. So can we agree that we see x, x, and blank 2 times here? X, x, and blank. So what we want to be able to do is group this little pattern as one total payment. Let me say this one more time. We want to group this total pattern as one singular payment, okay? Such that this section right here is considered to be a payment, okay? And you're going to get this in 2 seconds. So this is considered to be one payment. And with that idea, we could also say that XX right here is also a payment, okay? And with that being said, what I said is that we could group different set of cash flows at T0, at T1, T2, and T3 into one singular payment. And the reason why we're able to do this is because we know that this pattern will be the same forever. We know that this pattern will be the same forever. And that's why I decided to group x plus 0 as one singular payment. And we do the same thing right here. All right? Now, obviously, we're assuming that it continues in perpetuity. So now we have 3 different payments, okay? So in order to have a better understanding of what's going on, I want you to be able to kind of see how we're going to write down a sort of payment like this. When we group payments, what does that really look like? And I'm going to write that down for you. So that one singular payment, which is what we're looking for right here, we'll write it down as follows. Okay? Can we all agree that we have our x right here? But also, can we agree that because we told each other that we have a discount rate at 12% annually, and we know that these are years, that we're going to have to compound these singular payments one by one, right? Because we're looking at a total set of different patterns, okay? So can we agree that our x right here, okay, will be compounded once to T2 and then once to T3. So it's compounded twice at a interest rate of 12% annually, okay? All right? And then we have our other x. Let us use red. It's going to be compounded once to our T3, such that we have x 1.12 And then if we look at our last cash flow, T3, well, because it's 0, we don't need to consider how it's getting compounded, and because we know there's no value there, it's a non-factor. So our payment will be equal to x times 1.12 to the power of 2 plus x times 1.12. Now, what I want you guys to be able to understand is that we're grouping this payment as 1, okay? And because all these different payments are being compounded at a different set, we need to be able to just consider that when we place it. Now, another thing that I want you guys to understand is the last step, our k. Well, will our k be 12%? The answer is no. And the reason why our k for our perpetuity is not 12% is because in the question, and I'll put it in red, they're saying it to us explicitly that your k is on an annual basis. Okay? So you need to find your k for that period of 3 years because we grouped our payment as 1. And that one payment spans T1, T2, and T3. T4, T5, and T6, T7, T8, and so forth. So it's always spanning 3 years, 3 periods. So you need to be able to create an interest rate, or essentially compute an interest rate that represents the total compounding period. Okay? And in order to do so, what I want you to remember really quickly is that obviously if we have an interest rate of 12% per year, then of course our interest rate for 3 years has to be bigger. Okay? It cannot be smaller. So in order to find your interest rate, in order to find your k, you need to use the following set, okay? So you can find your k by doing the following. You can do 1 plus your k right now over 1 over 1 over 1 over 3 minus 1. Okay, that's the formula. The reason why I'm saying this is because what you're doing right now, if you guys remember your APR formula, all that you need to know is that this is the the different factor. Okay, is because we're compounding once every 3 years. We are compounding once every 3 years, so we have 1 over 3. And because when we use our APR formula, we need to place our first set right here as 1. And then we need to be able to put it over the compounding period. In this case, because we're looking at 1 over 3, we're looking at one compounding period over 3 years, we get the following, okay? We get k equals 1.12 to the power of 3 minus 1. And that gives us a k, if we do it together, of 40.49. Okay? So now we have all the different elements we need for our question. We have all the different elements that we need for our question such that we're able to place it on our data. So now let's do it in green. So our present value is equal to x times 1.12 to the power of 2 plus x times 1.12 over our interest rate that we found of 0.4049. And we know that our present value is equal to 1,262.23. So all that we have to do is do some quick little maths. Such that now you have, if you bring this right here, now you have 511.11 equals x plus x. Such that you're going to be able to find that your x is equal to 511 equals 2.3744 x, such that your x is equal to 215.26. Okay, and obviously you get your answer, which is D. All right, Really quickly, I want to be able to give you guys a quick clarification on how to find your effective period rate. That's exactly what we did, and that's why our K was 40%, 40.49%. And I understood that I kind of went quickly on that. And because I want you guys to really be able to master this, let me give you guys an understanding of how the effective period rate works. Now, you could use the following formula, which I'm sure you have in your formula sheet or it was provided by your teacher. So we know that the effective period rate is equal to 1 plus the quoted rate over m, okay? So over m to the power of m over f. F being your frequency, okay? F being your frequency. Minus 1, all right? Now the idea of f, this idea of this frequency is super interesting, okay? So of course, m being the year, by the way, of course, if we're dealing with a daily consideration, like we're dealing with right here, then we're gonna have in our m plus f section, so this represents our m over f. Of course, we're gonna have, if we're looking at compounded daily, of course, we're gonna have 1 over 365. All right? If we're looking monthly, then of course, we're gonna have 1 over 12 because we have 1 year and we have the frequency of compounding that is 12. So we're gonna have 1 over 12 for our MF. But we had something really interesting. We had 1 over 3. The reason for which we had that is because in that 1 year, we don't even have one compounding period. We only have one compounding period every 3 years, which is why we have 1 over 3, which at the end, as you can see, when we're looking at our formula or at the point of reference that I have right here, we could see that we're going to have 3, okay? Because 1 over 1 over 3 essentially gives us 3. So 1 divided by 3, that gives us 3. And also, just for a quick point of reference, if we have an annual consideration, so we have m being our year divided by the frequency of compounding periods, if it's 1 over 1, right, m over f equals 1 over 1 because we're looking at an annual compounding rate, then of course our exponent is going to be equal to 1. So that's just a little crash course on what that means. And I know when I'm speaking it, it's kind of weird, and maybe I should be doing a proof. And that's why I'm going to have it in our description below or in the crash course notes, such that you have a really good understanding of how we look at our effective period rate in real time. So with that being said, you were able to do a more complex perpetuity question. You were able to find how we find missing cash flows in real time. And you're probably going to see this on an exam, or this will probably be a assignment question that you're going to have to deal with.